All right, so next step, because this first model I used 24-inch wall concrete strength 9 all the way up, but still our deflection, especially Y, right, is exceeded over our criteria HO 500. So basically we need a more stiffness, right? So this is basically homework 1 and exercise, but we need to find the right stiffness. So going back to this, so I'm gonna go to save as M2. This is a Lateral model 1, but I'm gonna use M2. So we need to find how to improve that stiffness. The first thing is, since 24, uh, maybe just increase the wall thickness a little bit up to 28. So maybe I'm gonna try, but I'm not gonna go, wall. I'm gonna use the one constant wall all the way up. So maybe first thing I'll just limit to the wall thickness is 28, right? And maybe this case is 24. I'm gonna use 3 different wall thickness. Right? And then I have to assign this information. So what I'm gonna do, maybe I'm gonna click show story all, select this, right click, show only this member. Okay, I select all, only wall and link beam, but I'm gonna put it this only one story again. I'm gonna turn up the grid. So this, and then probably this time better use the section property color so that I can usually use and see visually which section I'm using and assigning. So this is one section property I'm currently use. So now I'm gonna put it on the XZ plane. I put it 0. So maybe this time I'm gonna assign in the middle joint with a different wall section here. Maybe this one is 24. All right, this one's I'm gonna use 20. The bottom, this one's using same color. I need to change the color palettes. So go to define section wall. Okay. Oh yes, I'm using different color. So let's refresh. Okay. So you see that? So 28 inches, 24 and 20 inches, right? Only change the wall. Now, basically, you need to change the link beam thickness as well, width as well, right? Together. So go to the frame, the link beam before 24 inches by 24. You need to change to width 28 to match the wall thickness. Okay, 24. Oh, did I? No. Okay. 20. I'm gonna change to 24. 24. So this one will match with the concrete, and 18 to match with the 20. So I'm gonna adjust the link beam thickness width to match with the concrete wall thickness, right? 20 by 24 C7. All right. So this is okay, C9. So I'm using 9,000 concrete. So 28 by 20, 28 by 24, or 28 by 24. And then I'm going to use 24 by 24, 20 by, and 24. Okay. So here you can select the beam by using window selection in the bottom, right? That the link beam that tie with 28 inches. Well, I'm going to assign 28 by 24 beam, right? And I'm going to select this, John, the link beam. I'm gonna assign 24 by 24, and then I'm gonna select this 20 by 24. Maybe this is also has the same color. So let me change the color. This one, I change the red, and this one change to blue. So okay, see the different color set, right? So link beam here 28, 28, 28 by 24, so that match with the wall thickness. 24 by 24 link beam match with the 24-inch wall. Also 20 by 24 match with the wall 20, right? So this is a one set I adjusted. I'm gonna show right click and show all. I'm gonna run the model. So this is model 2. So let's see how much deflection is reduced. So we try to kind of limit the wall thickness more reasonable up to 28, but even though the building is a little leg up in their stiffness, I just reduce the wall thickness a little bit as goes up, and if still I cannot meet the deflection criteria, I'm gonna use outrigger trusses. So now this case I'm gonna go up here, choose the 0.6. Right, so deflection, okay, slightly reduced down here, right? Let's see, select, copy, okay, and here is another set. All right, so basically this is also dx and dy, but different set. This is model 2, so maybe you can type the model 2, so you know what is a model 2 all about. So now I'm gonna add a section. This case model 2 dx deflection, model 2x is here, model 2 y-axis is right there. Oh, okay, I'm gonna add another m2 dy, x-axis is deflection, y-axis is floor information. Okay, so y deflection is slightly reduced, but still it's not enough, right? See, the m2x direction is no issue because wind loading is quite small because we're building deflection, and but still the building, when you look at it, I'm gonna say the building is wider in this surface here. So now we have to think about different strategies. So I'm gonna put the plan. So yes, wind loading in this, we have a surface length is much bigger than in wind blowing X. So wind blowing Y has a more significant the wind, but also looking at the wall layout, we have a weak axis in wind uh, against the wind at Y, right? So next step is we're gonna just rethink that we're not gonna increase the wall thickness because increasing wall thickness is very slowly adding the stiffness. Instead, we're gonna add the outrigger trusses. So next video, I'm gonna show you how, if you have some situation like this, the next step is we need to think about outrigger truss. Okay, so I'm gonna stop here.